Hi everyone, today we're going to take a very quick look at different ways that we can separate out mixtures. So here are 4 different types of separation techniques. One thing that we'll key on today is whether we're dealing with homogeneous or heterogeneous mixtures. And just so you know, we're going to get a lot of practice doing these actual techniques in class. So let's say we want to separate out a heterogeneous type of mixture. So we're looking at a colloid or a suspension. We have these big particles. One way we can do that is we can pour it through some filter paper. So this behaves a lot like if you've ever made coffee. You have coffee grounds in filter paper. You pour a liquid through, and the liquid's going to carry some of that caffeine and what we know and love as coffee into the bottom. This is similar, although we're not carrying liquid through. We're trying to separate the liquid from the big particles. And so you'll notice over here on the right-hand side, if we pour that through this funnel with filter paper, the solids are left up here on top while the liquid drains through into the flask below, and we've separated them. What if we want to do a similar type of deal, but we want to do it to a solution? So we have really small particles. Those particles are so small that they'd go right through the filter paper. Here's one method. We can do something called distillation. So when we distill, we have our initial mixture over here in the flask on the right-hand side. And if we heat it up, you can imagine, let's say that this is salt water. It's NaCl mixed in H2O. If we begin to heat this thing up, the water has a much lower boiling point than the salt. The salt is going to be pretty much impossible to boil, especially with this Bunsen burner. And so the water gradually will be boiled, and it'll go up here as steam, and it'll make its way over here to this tube that we are going to chill with cold water. And as we chill it with cold water, that's going to take the steam and condense it back into liquid water, and it's going to drip all the way over here into the collection flask on the right-hand side. So if we let this run for a while, gradually we're going to be left with solid salt on the left-hand side, and we'll collect our water on the right-hand side. Now there's a quick and dirty way of doing this if you don't care about collecting your water or time is not an issue for you. So we can do something called crystallization. Crystallization is essentially doing the exact same thing at a slower rate. So if you just let salt water sit out for a long time, let's say you let it sit out for a week, gradually all of that water is going to evaporate. You'll be left with salt, but the difference here is it takes a long time, and the water that is evaporating, you're not trying to collect it. So it's just going away, it's going into the atmosphere, and we don't care to try to get it back. The last technique we should talk about is called chromatography. Chromatography is a way that we can separate different parts of a mixture based on polarity. So I'm going to write down polarity here. This is a big factor that we know a little bit about. So basically, if I have a polar solute sitting over here, this thing is polar, and I run a polar liquid like water through it, that's going to pull the polar part of the solute over here, and if I had nonpolar, pardon me, if I had nonpolar over here on the left, and I run that liquid water, I'm having technology issues. If I run that liquid water through the nonpolar solute, it's going to go right through. It's not going to pick up any of the nonpolar solute, so we won't really see anything over here. It's not going to get pulled quite as far. So we're going to do a few different labs where we try separating based on chromatography as well. So let's get a little bit of practice. If you'd like to pause and try this, feel free, but let's explain how you would separate out a mixture of sugar and water. Hopefully you had a chance to pause and try this practice problem. Here's one way we could think about this. Well, we could distill, right? So if we distill, this is the one where we are going to have this big kind of apparatus, and on the left-hand side, eventually we'll have this flask, and in the flask we're going to have some sugar. But what did we do? We took water and we boiled it up and over through this condenser, and eventually we got this flask of water over here. And that's a really good way to separate these things. It's quick, but it takes a lot of energy to do that. And so you'll notice when we do this, we get back our sugar, we get back our water. Another method we could have used is crystallization. So let's say we don't care to have the water back. If we just let our sugar and water sit out, pardon me, can't spell sugar, let's try again. So if we have our sugar and our water sitting out, gradually the water is going to go and leave, and at the end of the day, we will have our sugar, but our water will be gone. It's going to have left into the atmosphere.